Hello everybody, today we're going to solve a system of three linear equations. So here we have our three equations. It would be a good idea for us to number them. The first one is equation 1, equation 2, and equation 3. Now, the goal here is to try to see if we can eliminate a variable by adding two equations. If you notice, if we were to add any two equations, no variable is going to eliminate as is. However, if you notice the coefficient of x is 1 and the coefficient of y here is -1. So you can use these to eliminate x or y in other equations. So let's take, for instance, equation 1. Suppose you multiply equation 1 by -2. This would give me -2x. If I were to add it by with the second equation, it would eliminate x. So what we can do, we can multiply equation 1 by -2 and add it to equation equation 2. So if I will multiply this by -2, what's going to happen? So let me rewrite it here just so that everybody follows here. If I were to multiply, this is equation 1, and I'm going to multiply it with -2. That would give me -2 times x, that's give me -2x, -2 times 3y, it's -6y, -2 times 2z is -4z, equal to -2 times -3, that's +6. Now that we added equation 1 by -2, we're going to add it to equation 2. Equation 2 is 2x minus 5y plus 3z equal to 8. Now if you were to add them, the x is going to cancel out. And what you're left with, -6y minus 5y, that's -11y, minus 4z plus 3z is -z. And then if you were to add 6 and 8, you get 14. Now you have an equation with only two variables, as opposed to here having three variables. So now I'm going to name this equation. We have 1, 2, 3 here. This would be equation 4. So I use 1 and 2 to eliminate x, and we're left with y and z. Now I'm going to have to use 1 and 3 to eliminate x. Now again, if you were to multiply equation 1 by -3, so if you multiply equation 1 by -3, and if you add it to equation 3, what happens, it would eliminate the x as well. So let's go ahead. Equation 1, again, I'm going to write it down. X plus 3y plus 2z equal to -3. If I were to multiply this by -3, we would get -3 times x is -3x, -3 times 3y is -9y, -3 times 2z is -6z, equal to -3 times -3, which is 9. So this is equation 1 multiplied by -3. Now we add it to equation 3, that's 3x minus y plus 4z equal to 7. Here's equation 3 right here. We were to add them, this is going to cancel. -9y minus y, that will give me -10y. -6z plus 4z is minus 2z. And you're going to add 9 with 7, we're going to get 16. Okay, so this is equation 5. If you take a look at equation 4 and 5, what do we have? Well, equation 4, you have -11y minus z equal to 14, and equation 5 is -10y minus 2z equal to 16. We have a system of two linear equations. That's something that you've done before. You can solve by graphing, substitution method, elimination method. I'm going to use elimination method. Take a look. The easiest one to look at is here. We try to eliminate z in here. If I were to multiply the first equation by -2, this becomes +2z, and that would cancel with this. So multiply this equation by -2. That would give us Negative 2 times negative 11y, that's going to be 22y. Negative 2 times negative z, it's going to be plus 2z. Negative 2 times 14 is negative 28. We're not changing equation 5. And as you can see, if you were to add them, the z going to cancel out, and you're left with 22y minus 10y. That will give us 12y. This cancels, equal to negative 28 plus 16. Negative 28 plus 16 is negative 12. You divide by 12, we get to solve for y. And here we have y equal negative 12 divided by 12 is negative 1. We got the solution for one variable y. Now we have to find the answer. We have to find the solution for x and z. So let's take a look. First, after you find one of the variable here, you have to solve for the other variable in these two equations. So we found y, now we need to find z, either from the equation 4 or equation 5. Okay, so let's go ahead and take equation 4. Equation 4 before simplified. So equation 4 is negative 11y. Y is negative 1 minus z equal to 14. So you can see equation 4 in here and in here. Okay, now you get to solve for z. So negative 11 times negative 1, that's 11, minus z equal to 14. Subtracting 11, we get negative z equal to 3, and multiply everything by negative 1, we get z equal to negative 3. So we solve for y and we solve for z in here. Now we're left with x. And the way you solve for x is by going back to one of the equations here, either equation 1, 2, and 3. Since we found y and z, we can easily now solve for x. So let's go ahead and use equation 1. Using equation 1, you plug in the values of x and z in there. So that's what I wrote down here, equation 1. So x plus 3y, what's y? Y is negative 1 plus 2z, z is negative 3, equal to negative 3. So x, 3 times negative 1 is negative 3, 2 times negative 3 is minus 6, equal to negative 3. So x, negative 3 minus 6 is negative 9, equal to negative 3. You add 9 on both sides, we get to solve for x. So x is equal to negative 3 plus 9, that's 6. So the solution to the system is x, y, and z. X is 6, y is negative 1, and z is negative 3. That is the solution of the system of 3 linear equation. I hope you find this video helpful. Have a good day, everybody. Bye-bye.